everyone. So now we're going to be talking about how to graph systems of inequalities. Um, when we do systems of inequalities, there's no real way that we can solve them because there's several different options for the answers of systems of inequalities, but we can graph them so that we can see all of those options. We're going to go through several examples, but before we do that, let's just go over some rules to graphing inequalities. The first thing that I want you to remember is that if we have a less than or a greater than sign, the line when we graph is a dotted line. And then if it's a less than or equal to or a greater than or equal to, it's a solid line. Then there's if I have y is less than or y is less than or equal to, that means that we shade below the line. And if it's y is greater than or y is greater than or equal to, we shade above the line. And this will make a little bit more sense when we start doing these examples. So let's get started. The first example is y is greater than or equal to negative x plus 3. And because it's a system, we have two equations. Y is less than 4x minus 2. Okay, I'm going to just draw the graph. All right, so the first thing I'm going to do is just graph the first equation like normal. So the y-intercept is 3, so I'm going to go up to 3, put a point there, and then the slope looks like it's -1, so I would go down 1 and to the right 1, down 1 to the right 1, down 1 to the right 1. I could continue. I could go up 1 and backwards 1, but we just need enough to draw a line. Okay, so now we have this line. Because it has that equals to sign underneath of it, we know that it's a solid line, so I'm just going to draw the solid blue line right here. All right, cool. So now, because it's y is greater than or equal to, if you notice from our rules, the greater than or equal to, I said that we needed to shade above. So I'm just going to kind of go with my blue pencil and shade up here. All right, now let's go back and do the second equation. So the second equation is y is less than 4x minus 2. So I'm going to start with the y-intercept, which means I go down to -2. Then my slope is 4, which means I'm going to go up 4 and over to the right one. So 1, 2, 3, 4 to the right one. I could keep on going, but we don't really need to do that because we know where the line's going to go. So this time I'm going to do it in red. Because it's just less than and not less than or equal to, we know it's a dotted line. So I'm just going to draw dotted lines like this. And then because it's y is less than, that means that we shade below the graph. And so we're going to just do this. And if you kind of notice, I know I didn't do a great job, but in fact, let's do like a purple because red plus blue is purple. Right where they're doubly shaded is kind of where our solution set is. So right here in this chunk, that's where all of our answers could potentially be. That's how we graph. Okay, so now let's do the second example. And the second example is y is less than or equal to -5x plus 2, and y is greater than -3. All right, so let me draw my graph. All right, so we're going to start with the top one. We start with the y-intercept, which is 2, and then the slope is -5x, which means I'm going to go down 5, 1, 2, 3, 4, 5, and over to the right one. Because it's less than or equals to, we're going to draw a solid line. So there's our solid line. And because it's less than, we want to shade below that line. Okay, now we're going to draw, we're going to graph the y is greater than -3. So y is greater than -3. There's no slope, but we do know the y-intercept is -3. So I'm going to go down 3 and put a point there. And because there's no slope, that means that the slope is 0, which means it's a horizontal line. So I can put the other point like right here. And because it's just greater than, not greater than or equal to, it's going to be a dotted line. And it's greater than, which means we shade above that line. All right, so like the last time, let's get that purple out. And we're going to look for where it's doubly shaded, which happens to be like right here. And that's our solution set. All right, now let's look at another example. And this example is going to be 5x plus y is less than negative 3, and then x plus y is greater than 1. Oh, man. Sorry, guys. All right. So these ones, instead of being in slope-intercept form, they're in standard form. The first thing I'm going to do is convert them both to slope-intercept form because it's going to be much easier for me to graph them that way. So let's take this top one, which is 5x plus y is less than negative 3. I want to solve that for y, so I'm going to subtract 5x from each side. And I end up with y is less than negative 5x minus 3. All right, and then let's do x plus y is greater than 1. I want to get the y by itself, so I've got to move the x. I'm going to subtract the x from each side. So I get y is greater than negative x plus 1. All right, so those are my two equations that I want to graph. So I'm going to start with the y is less than negative 5x minus 3, which means my y-intercept starts at negative 3, and then my slope is negative 5, which means I go down 5 and over 1. 1, 2, 3, 4, 5, and then over 1. I could also, from this y-intercept point, go up 5 and backwards 1. 1, 2, 3, 4, 5, and backwards 1. Just kind of depends on how much space you have on the graph and how many points you want to put on there. Okay, it's a less than, not a less than or equals to, so we're going to put a dotted line there. And then it's a less than, not a greater than, so that means we shade below that line. All right, now let's graph the other one, which is negative y is greater than negative x plus 1, which means we start at a positive 1 for our y-intercept. It's a negative 1 slope, which means I go down 1 into the right one. I could also go up 1 and backwards 1. So there's our points. It's not a or equals to, so it's a dotted line again. So that's what it looks like. And this is a greater than 1. So we shade above the line, which is right here. Okay, so where it's doubly shaded is where I'm going to put the purple, which kind of is like in this little corner right here. So that is our solution set. All right, let's do one more. Number 4. Okay, this one is 2x minus y is greater than or equal to negative 1, and then 2x plus y is less than or equal to negative 3. All right, so once again, these are both in standard form, so the first thing that I want to do is solve them both for y so that it's in slope-intercept form. So let's just start with 2x minus y is greater than or equal to negative 1. I want to get rid of the x first, so I'm going to subtract the 2x from each side. I get negative y is greater than or equal to negative 2x plus 1. I don't like that it's a negative y. I want it to be a positive y, so I've got to divide each side by negative 1, or each chunk by negative 1. But when I divide by negative 1, if you remember, the rules of inequalities means that if I divide by a negative number, the inequality flips. So this changes to y, or goes to y, which is what I wanted, but the sign flips from greater than or equal to less than or equal to. And then we've got negative 2x divided by negative 1, which gives me a positive 2x. And then negative 1 divided by negative 1 gives me negative 1. All right, so there's one of our equations. Now let's do the second equation. 2x plus y is less than or equal to negative 3. I want to solve this for y, so I'm going to get rid of the 2x by subtracting the 2x from each side. And I get y is less than or equal to negative 2x minus 3. All right, so here are my two equations. Let's draw a graph. All right, and then, so the first equation is y is less than or equal to 2x minus 1. We start with that negative 1, which is my y-intercept. And then the slope is 2, which means I'm going to go up 2 and over 1. Let's do it one more time. Up 2 and over 1. All right, and it's a greater than or equals to sign, which means it's a solid line. And less than or equal to, so I'm going to shade below that graph. Now let's graph the second equation, which is y is less than or equal to negative 2x minus 3. So I'm going to start at negative 3 and then go down 2 and over 1. Or I could go up 2 and backwards 1. And then because it's a less than or equal to, it's a solid line. It's a less than, so I'm going to shade below it, which means my purple shaded area, is right here. Now you don't have to shade in different colors. You can just make it like extra dark or extra shaded in that area just to show that that's where our solution set is. And that is how you